in input. So experiment then design of content-based recommender system. In this code, we are importing all the essential Python libraries needed to build a content-based recommender system. So, a simple print statement confirms that all libraries have been imported successfully. Uh, Load the dataset. In this code, we are loading a dataset named games.csv. Games.csv using the pandas library. The file path can be changed if the dataset is stored in a different location. We use pd.read CSV function to read the CSV file and store it in a variable called data. So here we load the data. Once the data is successfully loaded, we use print a confirmation message and then use data.head to display the first few rows, helping us quickly verify that the data has been imported correctly. So data loaded successfully. Display all column names to identify the correct one for product. In this code, we are checking which columns are available in a games.csv dataset. We use data.columns to list to print all the column names so we can easily identify which column represents the game name and product title. Next, we use data.head. Data.head. Um, Data.head to preview the first few rows of the dataset, giving us a clear idea of how the data is structured. Finally, a print statement, it confirms that the column 6 has been completed successfully. Here we can see the available columns in dataset and preview of first few rows and column check completed. In this step, we are performing a quick diagnostic check to confirm that our data has been loaded correctly. We print the list of columns names using list data.columns to verify the exact header in the CSV file. Then we use data.head to review the first few rows of the dataset. This helps ensure that the data is properly formatted and that the columns we need like game names, description are present before we move ahead with feature extraction. These are first few rows of data. Um, Data inspection. Display dataset information to first correct column names. In this code, we are again inspecting the games.csv dataset to identify the correct column names we will use for a recommender system. The command list data.columns prints out all available column names, helps us locate the exact one that represents the game title and possibly the description or general fields. Next we print first few rows using data.head to preview the data visually. This step is essential before feature extraction, ensuring that we reference the right columns in the upcoming IDF and similarity calculation. Here are first few rows. This section, remove leading and trailing white spaces from the game name column. In this code, we are cleaning the game name column of our dataset to make sure all entries are consistent. We first specify the column names as game name and then we use as type string.strip to remove any extra spaces from the beginning or end of each game name. This step is important because even a small white space differences can cause mismatches when comparing or searching for game titles. Finally, we print the confirmation message and display first few rows to verify that the cleanup was done successfully. So here is the output. Perform feature extraction using TF-IDF. In this code, we are transforming the game names into numerical feature using the TF-IDF. Term frequency, inverse document frequency technique. We create a TF-IDF vectorize the object with stop words in English to automatically remove common words like the or and. Then we apply the first then we apply the fit transform function on the game name column, which converts each game title into TF-IDF vector and a numeric representation that captures how important each word is in the dataset. Finally, we print Finally, we print a message confirmation that the feature extraction is complete and display the shape of the TF-IDF matrix showing the total number of games and unique words used for feature generation. This section computes the cosine similarity between the games. In this code, we are calculating the cosine similarity between all the games in our dataset. We use the cosine similarity function and passed in the TF-IDF matrix that we created earlier. Cosine similarity measures how close or similar to two text items are. In this case, how similar two game titles are based on their word composition. The result is a cosine similarity matrix where each cell represents the similarity score between one game and another game. Finally, we print a message confirmation that the computation was successful and display the message of the matrix, which shows the total number of comparisons made between all the games. So this is cosine similarity matrix computed successfully, and the shape of cosine similarity matrix is given. So create a function to display top end recommendation for a given game. In this step, we define a function called recommend games to suggest similar games based on the given game name. The function first checks if the entered game name actually exists in the dataset. If it's not found, it displays an error message. Next, it retrieves the index of the given game and uses the cosine similarity matrix to find how similar this game is to all others. We then sort these similarity scores in the descending order so the most similar games come first. To avoid recommending the same game, we skip the first item, which is the game itself. Finally, the function prints the top end recommendation showing both the game name and their similarity scores. The output helps users discover games that are most relevant in the terms of content, title, or description, which is the essence of a content-based recommender system. Input game name and number of recommendation. In this step, we allow the user to interactively input the game name and the number of recommendations they want to see. The code first takes the game name from the user and removes all leading or trailing spaces using the strict function, ensuring cleaner input. Then it takes an integer input for how many similar games the user wants, for example, 5 or 10 recommendation. Both these inputs are passed to the recommended games function, which we defined earlier. That function then finds the top and most similar games using cosine similarity based on TF-IDF feature. Finally, the system displays a neatly formatted list of the most similar games along with their similarity scores. The final print statement recommendation task completed confirms that the process was successful. This completes the interactive recommendation system where users can explore related games just by typing a game name. So here is the final step. Display dataset info and sample. In this final step, we perform a quick summary check to confirm that our dataset is correctly loaded and processed before generating recommendation. The code first prints the total number of records or rows present in the dataset using data.shape, which helps us verify that all entries are available and none are missing. Next, it prints the first 10 games names from the column defined earlier as column names, which holds are the main feature, usually game name. This step acts as simple sanity check to ensure that data is clean, properly pre-processed, and ready for use by the recommender system. So here is the print statement. Print data set summary. This clearly identifies your output for record verification during the day. படிச்சுட்டு அது கட் பண்ணிக்கலாம். Thank you.